Modeling fusion and fission. Fusion is the combining of elementary particles, protons and neutrons, to form nuclei. So, using marshmallows, you will demonstrate nuclear fusion, which took place in the first seconds after the Big Bang and is still happening today in stars throughout the universe. So you will need 4 mini marshmallows, 2 pasta pieces, and a table of elements. You probably have a giant table of elements on the wall in your chemistry classroom that you can use for this. So go ahead and pause this video and work through the activity and return here when you are ready to check your work. Question 1 here, it says find hydrogen and helium on the periodic table. Look at the big numbers above them. That number represents the number of protons in an atom of the element. So if we find hydrogen, we see that there's this 1 right on top there. That is telling me that hydrogen has 1 proton. Helium then has 2 protons. And beryllium, Be, would have 4 protons. So the number of protons is what dictates the type of element. So helium will always have 2 protons. If it doesn't have 2, it's not helium. So each marshmallow is going to represent a proton. Protons have positive charges, so they repel each other and don't want to stick together. So you will need to force the protons together here. So what element does each of the marshmallows or each of the protons represent? So this represents hydrogen with its single proton. During the Big Bang, the universe was hotter and denser than the center of the sun. These conditions are needed to overcome the repulsion between nuclei and allow fusion to happen. So in your hand, you squeeze together 2 marshmallows until they become 1 atom. So is your hand a good model of the conditions during the Big Bang? Well, the Big Bang was hot, there was lots of pressure/compression, and it was dark. So your hand has similar conditions, but to a much lesser degree. Obviously, your hand isn't millions of degrees hot. And what atom have we formed by smushing together those 2 protons? We have helium. So during a fusion reaction, a large amount of energy is released, which we will represent using a piece of pasta. So you experience that energy in the form of the sun's light and heat. So place that pasta piece next to the atom you just created, and you're going to repeat this process to make a second helium nucleus. So at this point, we've got a helium and a helium, and we have a pasta piece and a pasta piece. So this is the amount of energy that was released whenever we made helium. Well, if we combine these together, that's going to give us beryllium, Be. And the energy then is going to be twice as much as what it was for helium. So comparing the amount of energy released when 2 hydrogen atoms fuse to make helium to the energy used when 2 helium atoms fuse to make beryllium. So we had twice as much energy whenever we fused together the helium into beryllium. Lithium has 3 protons in its nucleus. So what's a hypothesis for how we could form this by fusion? Well, we could have hydrogen with 1 proton and helium with 2 protons combine to make a lithium. Now, the majority of the elements in the universe are hydrogen and helium. So does that make sense? Well, yes, there's going to be less helium than hydrogen because I need to make helium from hydrogen. So as that atomic number increases, in general, the elements become more rare, less abundant. Fission is the opposite of fusion, where a large nuclei splits apart into smaller nuclei. Like during fusion, energy is released during this process. So using a balloon, you will demonstrate fission. So you can go ahead and pause and work through this next section, and then return here when you're ready to check your work. So first you blew up the long balloon. This represents a large atom that is going to undergo fission. Twist near the center and hold both ends so it remains twisted. So you're going to have somebody cut the balloon at the twist. This is making fission happen. Release the ends as the balloon is cut. So what evidence do we have that energy was released during this process? Well, one, you probably heard a loud pop. That was energy being given off whenever that balloon is popped. And then the halves of the balloon move in opposite directions due to the pressure of the air inside of the balloon. So fusion is what happens in our sun. We take light elements like hydrogen and stick them together, fuse them into heavier. Fission is the opposite. We start with a big, heavy atom and we split it apart into smaller pieces. This is what happens inside of a nuclear power plant. So all of that energy that's released when you cut that uranium atom in half or whenever you break it apart, that energy is used to turn water into steam and turn turbines and make energy. So you have your next journal right. In this activity, we modeled fusion using marshmallows and fission using a balloon. In what ways is this model accurate? What does it fail to show about these processes?